In today's video, I'll be exploring the concept of wave-particle duality, which means that light behaves both a wave and a particle at the same time. So to understand this, I'll demonstrate some uh, key properties of, to show why light is a wave and a particle at the same time.
So first, I'm gonna talk about the wave properties of light, and I'm gonna go through four examples. First is interference, second is reflection, third one is refraction, and then the fourth one is diffraction. So I'm gonna talk about wave properties of light. The first example, which is interference. So basically, what I've prepared first for the interference experiment is that here I have a laser flashlight, and second of all, I have a paper here, which obviously I created two narrow double slit areas, which is right here, as you can see, which later what I'm gonna do, I'm gonna to use the laser and shoot across this double slit and then to show it up on the wall. So let's give it a try first to see if it works. Oh wait, not this. Here. It works. I can see two red dots appearing on the wall that the light waves does interfere. Yeah. Two red circles. So basically, yes. So interfere happens when two light waves mix, creating patterns of bright and dark band areas. Just like this. Similar to waves where, if the waves go peak to peak, then it is constructive interference. But if it's peak to trough, then it's destructive interference. Okay, this is not a very good example, but it's the least of what I can do here. So yeah, that's how it is. And the second example is reflection. I got a mirror here, and then I got, yes, the same O2, the laser flashlight. So as you can see, as I point towards the mirror, it reflects. So basically, light reflects off surfaces. Light reflects off surfaces just like waves do. For example, what I'm doing right now, the light hits the mirror here. So the angle at which it points and strikes towards the mirror equals to the angle at which the light bounces off. As long as it bends, this is the key point. So yeah, it bends and pinpointing towards another different direction when I shoot the laser towards the mirror. The third example is refraction. Refraction is when light bends as it passes from one material to another, like from air to water. So right now I'll show this by shining the flashlight into the sink and to observe how the light changes direction. I might as well turn on the faucet. So as you can see here, instead of being straight when comparing this between air and water, This bending effect is the characteristics of waves. The fourth example is diffraction. So it occurs when light bends around small openings or obstacles. So once again here, I have a piece of paper again, but this time instead of 2, I've made around 7 to 9, having multiple holes here. So I'll demonstrate this by shining the flashlight through these small holes, through these small little gap areas. So you'll see, on the wall, there's some light spreading that goes from top to bottom as I shine across the slits, the openings. So yeah, as you can see here, the light spreads out left to right and top to bottom, which is another example of wave property, because light waves spread out when they pass through small openings, which is a characteristic of wave behavior.
Light can travel through space, which is a vacuum, where areas have no oxygen and there aren't many uh, particles that exist in outer space. So yeah, this is why sunlight reaches uh, Earth from the sun. Unlike sound waves, light doesn't need a medium to travel. So I won't demonstrate this because, well, yeah, just to know that it's an important wave property of light.
So now I've gone through some of the examples of reflection, refraction, interference, and diffraction, about some of these examples of wave properties of light. Now I will go through the particles properties of light, which I will now go through the example of reflection and refraction, as well as explaining a little bit difference between uh, double slit and single slit experiment. The first example is reflection. So particles like marbles, which I got one right here. So they bounce off surfaces when they collide, just like light reflects. So now I'll roll it against a flat surface of the floor to demonstrate this. It bounces off and it bounces back. So this behavior is similar to how light reflects off mirrors. Second example is refraction, but when it comes to particles this time. So particles can change direction when they enter a new medium. For example, I'll put my chopstick into the glass of water. Looking at it from this angle, as you can see, whenever any object enters another type of medium, it bends, which has a minor difference in direction when comparing it to air, which is similar to how light refracts. So just now I've gone through uh, the particle properties of light between refraction and reflection. So now I will talk about a bit more about the difference between double slit and single slit experiment. So for right now, I will talk through about the example of single slit experiment. As you can see, I got what I needed. Okay, so I got my piece of paper, but this time with only one hole, which is this hole I'm gonna use. So I'm not gonna use one or two, I'm not gonna use 2 or 3, I'm only gonna use 1 hole this time. And yes, same old thing, I'm gonna to use the laser and shine through this hole, shine through this slit, this single slit, and pointing it towards the wall. Let me see if this works. Hope it does. Okay, it does. So as you can see, when particles pass through a single small opening, like right now, comparing to double slit, they do not create interference patterns like double slits do, because double slits have the effect of sharing the area in one space, causing the effect of waves from going trout to trout or peak to peak, of having constructive and destructive interference at the same time when they clash.
Unlike particles like marbles, light particles can travel through a vacuum without needing a medium. This is because this is what allows light to reach Earth from outer space, in which, yeah, particles like marbles and other objects cannot.
So, in conclusion, light behaves both like a wave and a particle, depending on the situation. Because through these experiments, we've seen how it reflects, refracts, diffracts, and interferes. So, and how it transmits through vacuum.